Hi everyone, so in this video we are going to talk about the PSAT. This also kind of applies to the SAT if you want to use it as a review for the SAT. Those tests are broken into three main areas: algebra, data and problem solving, and then advanced math topics. So this is about the first section, algebra, sometimes called the heart of algebra. So we're going to go through each of the topics in this section, it's mostly just Algebra 1 stuff. And I'm going to work through some problems. I highly recommend that you pause the video and try the problem yourself, and then watch me go over it. The first thing in this section is just solving basic equations and inequalities. Remember, when you are working through this kind of problem, you're just trying to get the variable by itself. That's it. Just move everything away until you get what you want. If it's multiple choice, like this problem here, you can always just plug in the answers. So if you can't figure out how to solve this, just test all the answer choices. That's going to probably take more time, but it's an option. So like if I put in 3 for y, does 3 times 3 divided by 2 minus 1 give me 8? And you can just put it in your calculator. That's 9 halves minus 1, so it doesn't equal 8, and so it's not that one. And then you could just go through each one and test them out. If I actually want to solve it, again, just get everything away from, in this case, the y that you're trying to solve for. Again, pause the video, try it, and then you can watch me go over it. When you are solving, you're going backwards in the order of operations. You're like undoing each operation at a time. So the first thing to go is addition and subtraction. I'll add 1 to both sides to get rid of that, leaving 3y over 2 equals 9. Then the next thing to go is this division right here. So to get rid of dividing by 2, I'll multiply by 2. That leaves 3y equals 18. And then divide by 3, and you get y equals 6. That's my answer, B. If you end up having extra time at the end of the test, you should go back, plug in your answers, and make sure they work. So for example, if I take 6 and put it in for y, does 3 times 6 divided by 2 minus 1, that's 18, divided by 2 is 9, minus 1, which actually is 8, so it worked, and so that's good. I know I got it right. When you were solving inequalities, the only difference is it's an inequality sign, like less than or greater than, rather than an equal sign. You solve these the exact same way, just like get the variable by itself. The only difference is if you ever multiply or divide by a negative, you have to flip the sign. So if it was less than, it would now be greater than. But that's only if you ever multiply or divide by a negative. Okay, let's start with this one. Remember, my goal is to get x by itself, but I've got x's over here and x's over here. So I need to get them on the same side. It doesn't matter which one, just get them on the same side. I'm going to move this over, but you could just as easily move this one over here. So if I subtract 5, 6 from both sides, 5, 6x, and then combine these, I'm going to do that in my calculator. So I've got 1/3 minus 5, 6, which is negative 1/2 x, plus 2/3 is less than negative 1. Okay, you've probably noticed there are some very annoying fractions here. So if you ever want to just get rid of the fractions, what you can do is just multiply everything by a number that would get rid of all of them. Like, do you see how if I multiply these by a 3, it would get rid of those 3's? But a 3 wouldn't get rid of the 6. So in order to get rid of the 6, I'd have to multiply by a 6. And 6 is actually good because then it would get rid of the 3's as well, because 6 over 3 would cancel out. So at the very beginning, we could have got rid of the fractions by just multiplying everything times 6, times 6, times 6, times 6, and that would have got rid of the fractions. We could do the same thing here too if we wanted by multiplying everything by a 6, and that would also get rid of these fractions. But this one's actually not that hard to just do anyway, if you just subtract 2/3 from both sides. Whoops. That leaves you with -1/2 x is less than, this is -3/3, and another -2/3 is -5/3. You can do that in your calculator if you want. Alright, we're almost done. There are a couple ways to get rid of the -1/2. The fastest way would be multiply by a -2/1. Because 2 and 2 cancels, 1 and 1 cancels, and negative times negative cancels. If I do it to that side though, I have to do it to this side as well. Times -2/1. Or just times -2. Notice, I just multiplied by a negative, and that's this rule here. If you multiply by a negative, you gotta flip the sign. So the less than becomes a greater than. I now have x by itself, and then -5 times -2 is 10 over 3 times 1, which is 3. So x is greater than 10/3 is my answer. There are other ways you could have got rid of this, like you could have multiplied by a 2 and then divided by a -1 or multiplied by a negative even, but you still get the same thing. Alright, I wanted to show you that occasionally you'll see inequalities that have multiple pieces, like this is less than this, which is less than this, and you work them out the same way, you just got to keep it balanced by doing the same thing to everything. So if I want to solve for x, I need to first get rid of divided by 5 by multiplying by 5. So just multiply everything by 5. That gives me -10 is less than, these cancel, and leaves 3x, which is less than 7 times 5, which is 35. Then, again, just trying to get x by itself, divide by 3, but you've got to divide everything by 3, and so that's my final answer. -10/3 is less than x, which is less than 35/3. Okay. Occasionally you'll be asked to rearrange equations, which is the same thing as what we just did, except that there might be multiple variables in an equation. But you work it out the same way, just solve for the variable by moving everything else out of the way. So, for example, this problem asks which shows the equation, this, solved for y. That's important. I'm solving for y, which is here, so get rid of everything else. The first thing to go is the addition stuff. So completely subtract 3x from both sides to get it away from 2y. You can put it in the back or front, it doesn't matter. But now I've got 8 minus 3x. Those don't combine because they're not like terms. And then to finish up, just divide by 2. And I have to divide everything over here by 2. And that leaves y by itself. I solved for y. 8/2 is 4, and minus 3/2 x will stay as it is. Which of those is that answer? So here's -3/2 x, plus 4 is plus 4. So just rearrange that, and you would get C. All right, let's get into some linear functions stuff. Just a reminder about slope. You're probably not going to be given this formula on the test. You'll need to know this. Slope is the rise over the run. It's the change in y values divided by the change in the x values. So you could use this little formula, subtract the 2 y values, subtract the 2 x values, and divide them. For example, let's use these 2 points here. So this would be like x1, y1, this would be like x2, y2. And just do -1 minus 3. That's the change in y values. And then 2 minus -2 is the change in x values, which is -4 over +4, which is -1. All right, on a graph, you can kind of just count like the rise over the run, the change in y versus the change in x. For example, this one is a little weird, but in this problem it asks, what is the slope of line L? And here's line L. And it goes through the point 0r and S0. I don't know what r and s are. That's okay, I don't need to know. I can still just use the slope formula, which says and it doesn't matter which point you start with as long as you keep it consistent. So like if I do r minus 0, I gotta do 0 minus s. Or if I do 0 minus r, do s minus 0. Let's do that. 0 minus r, that's the change in y. And then s minus 0 is the change in x. So that gives me negative r. And then s minus 0 is just s. So there we have it, negative r over s, which is a. All right, so that is how you find slope. And just a reminder, the slopes of lines that are parallel, they always have the same slope because they're literally sloped the same. If lines are perpendicular, meaning they form a right angle, those lines have opposite reciprocal slopes, meaning if one is positive, the other's negative, because like if this one's coming down, this one's got to be going up, and you flip the fraction. So what I mean by that is, like, say this one has a slope of positive 5, which is like 5 over 1, then this one would have a slope of negative 1/5. See how they're flipped and opposites? So that's what perpendicular slopes are like. So we're going to use that to answer this problem. What's the equation of a line that goes through this point and is perpendicular to this line? So I can graph it if I want, but I don't really need to because I know if my new line is perpendicular to this, it's going to take this slope, but the opposite reciprocal. So rather than 1/3, flip it, and that's 3 over 1. And also, since this one was positive, this one will be negative. That's my new slope. Negative 3 over 1.
Hunter Foster, please go to the media center. Hunter Foster, please go to the media center. Okay,
so you can do the point slope formula if you remember that, but I'm just going to use slope-intercept form, which looks like this. Y equals mx plus b. That's the equation of a line where you fill in the slope and the y-intercept. I already know the slope is negative 3. And what I don't have is the y-intercept. I could graph it, like I know it goes through the point 1, 2, and I know the slope is negative 3, so down 3 over 1, it would look like this. And I could use that to pretty easily find the y-intercept. Or I can solve for it by using this point. The point 1, 2 should go in my equation. It should make it work. So if I put in 1 for x and 2 for y, I can solve for b. So put in 1 for x and put in 2 for y, and now all that's missing is the y-intercept, and I can solve for it. So that's going to be negative 3 plus b, and then I'll add 3 to both sides and get 5. So that is my y-intercept. So now go back up to here, and instead of b, put in a 5. So that's my final equation, y equals negative 3x plus 5. So if you want to know if a point lies on a line, do kind of like what we just did. Plug it in for x and y and just see if it works. You could also graph it, but for example, does the point 4, negative 1 lie in the graph of this equation? All you got to do is put in 4 for x, negative 1 for y, and see if it works out. So put in 4 for x, and so that's 8 minus 9, which is negative 1, which is what we wanted to get. So it does work out. The answer would be yes. I just wanted to show you this. These are the exact same problem, It's just this one I made it a function and used f of x rather than y. It means the same thing. Remember that f of x is just a y. So when you're trying to test out that point, still just put in 4 for x and see if you get out -1 for y. Keep in mind that a graph is the set of all the solutions to an equation. So basically, like here's my equation, and every point on this graph makes that equation true. So like the point 0, 3, if I plugged in 0, I would get out 3. If I plugged in 1, I would get out 5. If I plugged in 1 point whatever, I would get out 5 point something. All of these points on this graph make this equation true. Nothing else does, just the points on the line. Okay, so keeping that in mind, let's get into systems of equations now. Remember that a system of equations just means multiple equations. It means something like this, where you have 2 equations, 2 variables, and you want to solve for both of them. You want to find an x and a y value that make both of these equations true. So that's this. You have to find coordinates that satisfy both equations. There are 3 ways to do this. The first is to graph it, because it's just where they intersect. This blue line represents all the solutions to this equation. The red line represents all the solutions to this equation. So the only point that works for both is right there where they intersect, which makes sense. So that's the solution to this system of equations would be 2, 5. If you plugged in 2, you would get out 5, and if you plugged in 2 here, you would get out 5. But if you plug in any other point, it's not going to work for both of them. What's the solution to this system of equations? Again, you just got to look for the intersection. It would be -2, -1. All right, so if you don't have graphs or if you don't want to graph them, there are 2 other ways to solve a system of equations. You've got substitution method and elimination method. Substitution is best when you've got one variable already by itself, like this. With substitution, you just substitute all of this in for y in the other equation. Basically, you take one equation and you put it in the other. You just substitute all this for y because it equals y. So when you substitute it in, you would get 4x minus 3, but instead of y, we're putting this stuff. So 6x minus 13 equals 25. The reason you do this is because now I only have x's, and so now I can solve for x and then go back and solve for y. You can't solve for both variables at the same time. I'm going to leave that there. We'll do more examples. The elimination method is where you add up the 2 equations and eliminate one of the variables. So do you see how when I add -4x plus 4x, that would just be 0? It goes away. We eliminated the x variable. -2y plus 8y would be 6y, and -12 and -24 would be -36. And then I could just solve for y real quick. So y equals -6. And then to find x, you just substitute either of these equations, substitute the -6. I'm going to use this bottom one here. So 4x plus 8 times -6 equals -24. And then if you solve this, you can find x. Okay. So in this example, I wanted to show you multiple choice. On the PSAT, most of them are multiple choice. And so if they give you the answers, you can always just plug them in and see which one works. So that's always an option. If you put in 5, does 2 times 5 minus 3 times negative 2, does that equal 4? And it doesn't. And remember, it has to work for both, so you'll need to test it here as well. Does 2 times 5 plus negative 2 equal 6? And I don't think that it does for either. So it's not A. So you could always just test the answer choices if you wanted. If I was going to actually solve this one, I could use elimination or substitution pretty easily. If you want to subtract 4x and get y by itself, you could substitute it in for y, and that would be a pretty easy way to go. You could also eliminate either of these variables pretty easily. For example, if I want to eliminate the y variable, I would need to have a 3y right here to add to the negative 3y so that it would cancel out. So if I want to have 3y, just multiply by a 3. The thing is, to keep it balanced, I got to multiply everything by a 3. So I would have 12x plus 3y equals negative 18. Multiply them all by the 3. The top equation I'll leave the same, and then add them up. So the y's are gone. This is 14x, and this is negative 14. Divide both sides by 14, and you get negative 1 for the x, and that's enough to answer the problem. Negative 1. If I needed to find the y value, I could use any of these equations. It doesn't matter which one, but take the negative 1, put it in for x, and use this to solve for y. So negative 2 minus 3y equals 4. Add 2 to both sides. So negative 3y equals 6. Divide by negative 3. That's how you get the negative 2. All right. Sometimes they'll ask you a question that won't let you plug in the answer choices. For example, this one gives you a system of equations, but it asks you what is the value of x times y. So when you get your two solutions, you're going to have to multiply them together. And so you're not going to be able to plug these in and test them and see if they work. This one I think I'm going to do a substitution because it's solved for a variable. It's actually solved for both. So you could go either way. You could plug this in for x in this equation, or you could plug this in for y in that equation. Just make sure you combine them. Let's do the first thing I said. So take all of this, and since it equals x, I'm going to put it in for that x, leaving me y equals negative 2 times x minus 3, but instead of x, take it out, put this in, 4y plus 3. And then just solve as you normally do. So y equals negative 8y minus 6 minus 3. I'm going to combine these two like terms, which makes negative 9. And since I've got y's on both sides of the equation, I'm going to move this over here to be with this sad little y. 8y plus 1y is now 9y equals negative 9. And then divide by 9. Y is negative 1. Again, that's not the answer yet. I need to go find x. Find x, easiest way is probably to use this right here, because I know x equals 4y plus 3, but instead of y, take it out, put in negative 1. So negative 4 plus 3, that's negative 4 plus 3, which is negative 1. So that's x, and this is y. So the answer of the coordinate pair would be negative 1, negative 1, but that's not what it asked. It asked for x times y. So if I do negative 1 times negative 1, that's actually positive 1. So the answer would be C. All right. One other thing to keep in mind with systems of equations is sometimes you don't get an answer at all. So if the two lines intersect, you get one solution. It's a coordinate, it's 2 points, like -1, -1. That's only one solution, it's 1 point, it's one x and y value. However, what if the lines actually end up being right on top of each other? In that case, they'd intersect along the whole line, and every point here would be an answer, and so there are infinite solutions in that case. Or what if the lines are parallel and they don't intersect at all? In that case, there are no solutions. So it's possible to get one solution, infinite, or 0 solutions. The way you can tell this on an equation is if both variables end up canceling out, but you get down to something that's true, something like 6 equals 6. Like, where'd the variables go? But this is true. That means there's infinite solutions. If you get something that's not true, like 0 equals 6, then there's no solution. Let me show you an example. This question asks, how many solutions are there to this system? Again, you could do substitution if you solved for x and substituted it in, or we could do elimination by multiplying by like a -2. That would get me -2x, and then -6y, and -4. I'll leave the top equation the same, but you may notice the problem is those cancel and also those cancel. All I'm left with is a 0. Nothing's left. Same thing over here. 4 minus 4 is just 0. So the variables are gone, meaning it's either infinite solutions or no solution. Since this is a true statement, 0 does equal 0, there are infinite solutions. So how many solutions are there? An infinite number of them. Basically, that means the lines actually were right on top of each other. This sometimes is asked in a weird way, so I wanted to show you a problem like that. This problem asks, for which value of the constant k does the system of linear equations have infinitely many solutions? So you'll notice in this system, it didn't actually give you the last number here. It just left a letter k, and it's a constant k, meaning it's by itself. This is supposed to be a number, but they put k in, and they're basically asking, if this were going to have infinitely many solutions, what would k have to be? So think about if I were going to use elimination. What would I need to multiply this equation by in order to get it to match up to this one? If I wanted to add these up and for them to cancel out, I would have to multiply it by -2, because -2x and +2y would then cancel out with these two. And then this right here, -2 times 3 would be -6. So it's asking, what would this number have to be in order for me to get a 0 over here and for it to equal 0 over here as well? Because if there are infinitely many solutions, it would have to be a true statement. And so -6 plus what gives you 0? Well, that would be 6. So that's what k would need to be, is 6. I wanted to point out that these rules of like, if you get a true statement, it's infinite solutions, and if you get a false statement, it's no solution. This actually works for any equation, not just systems of equations. So for example, it says, what's the solution to this equation? Just solve for x. Plain old, get x by itself. Let's work through this. First thing I'm going to do is distribute the 2. So we get 2x plus 6 equals 2x minus 10. First of all, just think through this. Could you multiply a number by 2 and then add 6? And then get the same thing as if you multiplied the number by 2 and then subtracted 10? It's just not possible. And you'll see why if I try to combine the x's by getting them on the same side, so subtract 2x from both sides, notice that it cancels, and it cancels here as well. And I'm left with just no variables. but I am left with 6 equals negative 10. That is not a true statement. 6 does not equal negative 10, so there's no solutions. Okay, let's move on to graphing. Just a quick refresher on this. Remember, when you're graphing a line, start at the y-intercept, which is the constant on the end by itself. That's your starting point. Negative 3. 1, 2, 3. Then the number in front of the x gives you your slope, the rise over the run. In this particular case, we could think of 2 as 2 over 1. So we're going to rise 2, run 1. Rise 2, run 1. Rise 2 over 1. Up 2 over 1. And there is my line. If it's a less than or greater than instead of an equal sign, all you have to do is graph the line as usual. So start at negative 3, go up 2 over 1, up 2 over 1. However, this doesn't equal the line, it's only less than the line. So rather than doing a solid line, I'm going to do a dashed line. And since it's anything less than this equation, it would be anything in this region, anything below the line. So if it's a less than, you should shade below. If it's a greater than, you shade above. This means any point in this region would make this inequality true. For example, like 2, 0, 0.20. If I do 2 times 2, 2 times 2 minus 3, is 0 less than this? So is 0 less than 4 minus 3? Yeah, 0 is less than 1. But if I try something on the line or even beyond the line, it won't work. You can even come up with combos of these. This is a system of inequalities, meaning just multiple inequalities. So here's the graph of this equation, this inequality is graphed above the line. This one's graphed below the line because it was less than. And if you want to know if a point is a solution to both, it's got to be in the double shaded region. So like 4, 0, 5, 1, those are solutions to both inequalities. They would make both of them true. This one has an equal sign, so it does equal the line. That's why we have a solid line. This one doesn't have the equal sign, so it's a dashed line. It doesn't include the line. So is 1, 2 a solution to this system? That's the point right here. It's very close to counting for this one, but no, it's not even a solution to the blue equation because it's on the dashed line. To be a solution, it has to be in the double shaded region. Okay, let's do a few problems with writing functions. So, in this problem it says, Naoya read a book cover to cover in a single session at a rate of 55 pages per hour. After 5 hours, he had 350 pages left to read. We're going to let y be the number of pages left to read after x hours. So x is time, y is pages left. I want to represent an equation to represent this relationship between the number of pages left and hours. It might help you to think through a few scenarios here. So like, after 1 hour, how many pages had he read? Well, if he's reading at 55 pages per hour, he's read 55 pages. So this is hour and pages. However, I'm actually trying to say how many pages are left, not how many pages has he read. It tells me after 4 hours, he's got 350 left. So we're going to need to think through, how do we get back to the first hour? Like, how many pages did he start with? Well, at the 3rd hour, there were 55 more pages than this. So add 55 and you get 405. And then add 55 again and you get 455. And then add 55 again and you're at 505. Sorry, I did this wrong. 350 plus 55 plus 55. Sorry, 460. Goodness. And then add 55 again. Something's off here. Oh, sorry. This would be 515. There we go, sorry. Got a little brain dead there for a second. And if I want to go all the way back to where you started, that would actually be at hour 0. That's what I was missing. Hour 0, add 55 again, and you get 570. So that would be the initial amount of pages left to read, backing up all the way to when time is 0. So the answer to this equation, this question is probably this one, the one that starts with 570. It's tempting to include 350 in your equation because that's what it gave you, but the 350 was already after 4 hours. So you got to back it up to your starting point, which actually was 570. You also could have just taken the 350 and added 55 1, 2, 3, 4 times, and that would have gotten you the 570 that you needed. Right, and then from there on, you just take the 570 that you start with and subtract 55 pages each hour. So do 55 times the hour and subtract it, because it's going down by that many number of pages. So B is the answer. That one's a little confusing as far as writing an equation goes. That's why I wanted to show you kind of a harder one. This one as well is a little weird. So Adina drove from the Dead Sea up to Oman. Her altitude increased at a constant rate. When she began driving, she was at 400. Her altitude is her height, so like sea level kind of thing. Her altitude was 400 meters below sea level. So she starts at negative 400 meters. And then by the time she's done, she's at 1,000 meters above sea level. So she goes from negative 400 to 1,000. And that was 2 hours. So let y represent her altitude relative to her sea level after x hours. So basically, how much altitude is changing per hour. Notice that she started at negative 400. So that should be our starting point, like our y-intercept, our initial value is negative 400. And from there, we're going to add her increase per hour. She went from negative 400 to 1,000, which is an increase of 1,400 meters, but that was out of 2 hours. So how much was she increasing in just 1 hour? Well, just divide those, and you get 700 meters per hour. So that's kind of like your slope. You'll take 700 and multiply it by the hours, and then starting at negative 400. If you rearrange those a bit, just rearrange them, you get A. Let's do an inequality now. So you bought 5 dresses for $12 each and X hats for $7 each. Your goal is to stay under a budget of 100. So just pretty much do what it says. 5 dresses times $12 each plus X hats times $7 each. And that has to be less than or equal to your budget $100. If you want to simplify this and make it a 60, you can, but either of those are accurate. All right, sometimes it might even ask you to interpret separate parts of an equation. So this one gives you, there's a voter registration drive held in a town. The number of voters is V, registered T days after the drive began. And it can be estimated with this equation. So we start with this, and then we're adding 65 voters per T, which is day. So we're starting with this many voters, and then we add 65 each day, basically. And so the interpretation of 65 what is not how many you started with, it's how many you're getting per each day. And so it's not the beginning or the end, or even the total, it's the number
at
each
this time you
day.
may dismiss your car drivers. Car drivers dismissed at this time.
If it asked what this number represented, that would be the initial number of voters, but it asked what 65 represented, which is the amount each day that you're gaining. All right, just a few more things. Just I want to remind you about how to simplify expressions, which we've kind of been doing this whole time, but anytime you can combine like terms, you want to do that. And anytime you can distribute, you want to do that if you're trying to simplify. For example, this one has a lot of terms, but some of them are alike, meaning they have same variables, the same exponents. For example, 2x and negative 10x are like terms. That makes negative 8x. We've got, well, none of the rest are actually, because this one's an x squared and there are no other x squareds, so I'm just going to leave it as it is. This one's an xy and there are no other xy's, so I'm just going to leave it as it is. This one's a y squared, there are no other y squareds, and this one's a y cubed and there are no other y cubes, so that's it. That would be my simplified answer. I combined the only like terms that I could. This one I need to actually distribute first and then combine like terms. So distribute the negative 3 to get negative 12x plus 3. And then you can combine negative 12x and 10x, which makes negative 2x. 3 minus 3, those cancel out, and that's just this. Anytime there's anything in front of parentheses, you got to distribute it all. So like, in this case, this is not directly in front of the parentheses, the negative sign is. And so the negative, this is like a negative 1.
Okay, teachers, at this time, dismiss your car riders. Car riders dismissed at this time.
And that negative 1 needs to be distributed to anything in the parentheses after it. So negative 1 times x squared is negative x squared, and negative times negative is plus 6, and then you can combine this stuff with this stuff. So now you have 2x minus 5. The x squared doesn't combine with anything, so we'll just leave it as it is, minus x squared. The 2x also doesn't combine, but negative 5 plus 6 makes 1. So that's my final answer on that one. On this one, all of this is in front of that parenthesis. So I need to distribute both of these to both of those. So do 2x times x squared, which is 2x cubed, because x times another x times another x. 2x times negative 6 is negative 12x. Oops. Negative 5 times x squared is negative 5x squared. And negative 5 times negative 6 is positive 30. None of those are like terms, so I'm just going to leave it. You might want to rearrange it, but on this one, I'm not going to work through this, but
All right, wave 1. We have 38, 44, 13, 6, 122, 87, 125, 77, 121, 106, 60, and 81. Repeating wave 1, we have 38, 44, 13, 6, 122, 87, 125, 77, 121, 106, 60, and 81.
okay, we're almost done, I promise. On this one, I'm not going to work through it all, but you would need to distribute everything here times everything here.
We do have 2 bus changes today. Bus 14 will ride bus 57 in the mornings and the afternoons until further notice. Bus 3 students will ride bus 10 this entire week.
We just have one more problem. Okay, anytime you've got something squared, that means multiply it by itself. If it was just one term squared, you could just square all the things in there and be fine. But if you ever have more than one term, you have to actually multiply it all out. So this squared means multiply it by itself. And so you'll need to distribute, like we just did, all of these things. 3x to the 4th times 3x to the 4th gives you 9. And then if you have 4 x's and then another 4, you now have x to the 8th. 3x to the 4th times negative 10 is negative 30 x to the 4th. This is also negative 30x to the 4th. And then negative 10 times negative 10 is positive 100. And we're almost done. These two in the middle are like terms. They don't cancel. If you've got negative 30 and another negative 30.
All right, last call for wave 1. We have 38, 44, 13.
You get this.
6.
So that's the final answer, and we are done with that section.
125.